Machine pencil cartography. So today I want to discuss something which has been a topic of interest to me. I like to hang out with my friends who use Blender, the 3D modeling application, and there is this new thing in Blender called geometry nodes, which everybody is anxious to get experience with because it is so new. This is actually what got me interested in surgery theory. Because I was doing independent research on what the best approach to this problem is, and what I discovered when doing independent research was that our procedural techniques can emulate the way that these structures are formed in the real world by researching topics from geology such as stratigraphy. The current state of the art for geometry nodes perhaps is not where it needs to be in the long run, but I would like to put my hat in the ring to discuss some of the current capabilities and how these capabilities might be further developed. I am aware that geometry nodes users have been able to produce building generators, where you can essentially click a button and the program will generate a building for you. So the place I am right now is that I assume that a building generator will be available for me. And I am preempting what might occur in this environment, where undisciplined new users will not respect the power of the tools that they have been given. They will attempt to have buildings constructed anywhere they want, without so much as consideration for where the buildings are being placed. I am talking about your teenage cousin who wants to build an underwater Minecraft base, but doesn't seem to realize that the water is going to be a pain in the ass and make this construction project 1,000 times as expensive as a construction project would be if you had just put the base on regular ground. So I have gone and performed some subject matter research, and it turns out that this is a common topic in structural engineering, because structural engineers are contracted to place buildings where the customer wants. I started my career with the goal of doing cartography, and now with the goal of being a structural engineer. So my preferences are not to encourage my users of pivoting career paths into structural engineering. Instead, I will go ahead and study the basics and make the wisdom of this field available in a context and form that might be relevant to a cartographer. My proposal would be that a cartographer should think about it in this way. We have geographical diversity. We have environments such as bathymetry environments, orogenic mountain environments. We have grassy plains, and whatever geographical landscape you might be working with in your current project should be just fine. The fundamental concepts of structural engineering are that your building must have a solid foundation. If you want to learn more about this topic, go watch Practical Engineering on YouTube. He will tell you plenty about building foundations. They're available on YouTube. The lessons that we will learn if we study building foundations are that your building should have some flat ground underneath it, and that it is very common for an engineering team to level the ground first. It is actually almost always the case that an engineering team will have to dig a hole under the building in order to install a foundation underground. The building's foundation should have level ground, so what this means for a cartographer who just wants dozens of buildings in their scene could be that they should take the normal direction of the ground and create a mask in your building generation plugin so that buildings can only be constructed on level ground. This means that if we have a mountain landscape and we have an inclined plane that goes at a 30-degree angle, but we have a U-shaped valley underneath, we will expect that the structures avoid the inclined plane area of the mountain landscape, and that there will be only a few sparsely constructed buildings that are located in the U-shaped valley, because these are the areas which have ground that is flat enough for the foundation of a building to be built on. Therefore, the idea is to create a mask for our building generation application that targets areas which have acceptable predicate conditions for generating and supporting the foundations of the structures that you are trying to generate on that land. This way, your building generator will not generate fundamentally incoherent structures, because your building generator is context aware and is at least checking the ground underneath the building to see if the terrain has a proper foundation, before it negligently slams a template building onto that plot of land. So my proposal is to write a topographical application that checks the terrain for suitable foundations. The result of this study will be a color-coded raster map, where the raster layers represent the suitability for construction, and it will interpret things such as the flatness of the land and perhaps nearby bathymetry features, and attempt to model the suitability for construction as a cartographic map layer, meaning a raster. The final product might have an area clearance where it will describe the size and weight of the building that this foundation could support. The area can be measured in square meters, and the weight can be measured in metric tons. Thanks, this has been Machine Pencil Cartography signing out.